Welcome back, everybody. I hope you had a good lunch. It's impressive the way he could make those puts and the speed he did. I thought it was very, very impressive indeed. We're sticking with the theme of powertrains. We're at this point on the agenda right now, almost at that time. Rasmus and Florian from ECAP are going to talk about battery and fuel cell powertrains for the next hour and a quarter. We're going to try and we need to respect this Baucat, this endpoint here, because in the break we set up for a debate, and then we have Brian Van Matthiasen waiting to join us at 3:15. So we have to be fairly sharp about that one. So if you see me waving at you at 3, that's the reason why. Okay, but we will fit in a break there so we can.
And you will be fair, so we get 50-50.
Yeah, exactly right. Yeah. So that's and it's all ready to go. So without further ado, Rasmus to talk about powertrains. Let's go, Rasmus.
Great, thanks. Okay, thank you very much, Philip. Can I use this?
Yeah,
I will. Yep. Okay, you've seen some of the machines, you've seen some of the powertrains out there, and now comes a little bit the technical part. What's inside and what is it that the bank actually offers in this context? As Philip said, I will be focusing on battery electric. I'll also talk a very little bit about fuel cell electric powertrains, but Florian will be going into more depth about that. You probably realize now that working vehicles are our thing. That's what we target in our business, and I'll talk a little bit about that market, and I'll say something about what can you buy from the large truck manufacturers today. How are they targeting this? Seen from our perspective, of course, we can't know what they're thinking, what they're doing, but we can observe, and I'll be talking a little bit about that. We can also see where are the niches that we may fit in. I mean, what is it that we know that our customers need, but they can't buy at present? And then, of course, I'll tell you how we try and solve some of that, and which markets we are targeting. If we look at what's being sold in Europe, it's actually quite a lot of trucks, something like 360,000, or at least it was according to Deloitte's Global Truck Study in 2016. I don't think it's changed so much. 350, 360,000. Most of these apparently are long haul. Then there's also a lot sold for city distribution, and then there are a group left, less than 10%, which are working vehicles. That means refuse collection vehicles, sewage vehicles, other specialist equipment vehicles, which tend to tap into these kind of vehicles, same platforms, to get to their solutions. These are all being addressed today by the big OEMs. They do it in different ways. Scania has a quite significant market share already in full electric vehicles. They are there with the 3-axle vehicles for city distribution. They are also there with a low cabin for with the same chassis for refuse collection. They have a concept where they have a direct electric drive, and now they are also offering an electric PTO. Sometimes it's manufactured here, sometimes it can be someone else, but anyway, it will be a dedicated solution to whatever is sitting on that truck. If it's a big crane, we need one kind of ePTO. If it's a smaller crane, we need another kind of ePTO. That's the way they're going. Daimler with the e-Actros and also the e-Iconic, specifically for refuse collection, same story. Chose a different strategy in terms of driveline. They have an electric axle that they use for these vehicles. They too have chosen to, at least in the outset, to have only a plug where we can plug our ePTO in to power whatever is on the truck. Then we have DAF, very similar to Scania's concept. They also need an ePTO. We have one sitting right out here. And finally, Volvo, who has a different concept again, which is actually similar to what we are doing on the full powertrains. And that is electric propulsion in combination with automatic transmission. and a mechanical PTO. So no ePTO required over here, at least not always. So these are the different approaches that we see. They're all great products, but not all are just as suited for all kinds of work vehicles. And they also address or target different areas. All of them will kind of work for everything, but they won't be equally well suited for everything. Look at a vehicle like the sewage truck. It's something that we think will be one of the areas where other solutions are needed, because we have enormously energy consuming body attached to the vehicle, even more power and energy consuming than actually the propulsion. A completely different setup, but maybe, I don't know how many sewage vehicles are sold in Europe, but it's in the very few thousands per year. So that's a niche which is addressable for customized solutions like we make. The same with the street sweepers, also very highly energy consuming. There you have a different problem. There's no space for batteries because that's where you have your sweeping and your suction of material. You also need different solutions for that, different placement of batteries. Of course, the refuse segment, again, you have conflict on the side loaders with battery placement and also high energies. And of course, you see some places that you need specific narrow vehicles, you need specific low vehicles, or other types of issues. And of course, we have a very, very large installed space of heavy-duty working vehicles that are not worn down but need to be electrified because no one will tolerate the diesel engine anymore. We have to remember that more often than not in these vehicles, the body represents a greater value than the chassis. You want to keep that body. You want to make sure it gets a second term. Also, I mean, we all know that circular economy is a buzzword, but we also have something called depreciation that is significant in this context. So today, if you want to buy a fully electric vehicle, you can do it. It will cost something like 3 million Danish or 400,000 euro for an application like this, or you can refurbish it for half. That's the reality today, and that's certainly a niche that we will be addressing. So refurbishment is always there. We have the capabilities to electrify more or less any vehicle, but we tend to stay with the customers we know. So refuse is definitely a market we'll continue to focus on. We can systems integrate to also partial electrification. We'll continue with the ePTOs, and we can offer now different places to put the batteries, other battery technologies, and so on and so forth. But our model is not to build vehicles ourselves. We provide the kits, and we recommend that you find somewhere else to do it. Sure, we can refurbish few vehicles for you, but in general, we will be the kit supplier, and you will need a systems integrator to make ends meet. A little bit about the driveline itself. Because we are addressing refurbishment and because we are addressing the working vehicle where the body is just as important as the truck itself, we try not to interfere with the truck itself. We electrify it on the existing truck's terms. We don't take out the transmission. We don't give it a new cooling system. We don't try to change the geometry. We don't change the brakes. We don't change the axles. Reuse everything that's there. The driveline will be powered in the same way as the diesel engine or CNG engine that was there before. It will be exactly the same. It will behave in exactly the same way. It means that the truck will drive in exactly the same way as it did before. If there's a transmission, we will use it. We can also do it without the transmission. But if it's there and it's a working equipment, it's great if there's a transmission, because then we can also power our body, and we have the power to power the body. So a mechanical power takeoff on a standard transmission is really a great thing if you own a sewage vehicle or a refuse collection truck. air system and so on. I'm not going to go into so many details about it, but more or less the same story. All we do is we switch the source of the compressor. It's not sitting on a belt on the diesel engine. Instead, we power it with an electric motor. We don't touch the brake system itself. And that's important in terms of homologation and so on. Cooling system, the same. It's a big task here because cooling system is, at least in this country, also the heating system. And we don't always have a fuel cell to give us heat. But we want to harvest that energy that we have in our cooling system. And sometimes if we have a transmission, we also cool that transmission. It gives us heat for our cabin. So that's something that we are spending a lot of time on, because if you don't harvest the energy, all of the energy, you are using battery capacity that we don't want to pay for. We have to do it, but we try to minimize it. The powertrain that we make is made up of a standard battery pack of 193 kilowatt hours. We can also make it to 386 kilowatt hours by adding batteries between the axles. It weighs something. The whole system weighs about 1,700 kilograms. So you can take away what your engine and your exhaust treatment system and so on, and you will end up roughly where what we are adding in terms of weight. And it comes to round about 1 ton, which is also what the road authorities will give you for free in extra payload, because you're running on a emission-free truck. A little bit more if we take 257 kilowatt hours, and of course a lot more if we take 386 kilowatt hours. And this, by the way, continues up to 750 kilowatt hours if we really have a highly energy demanding application. We use lithium iron phosphate, and we've been doing that for 10 years. This is a specific battery chemistry, and we are happy we made that choice 10 years ago. We're going to continue down that route. It's a safe chemistry. We can manufacture it safely. It's not the cheapest, but for this kind of application has the longest lifetime. We can predict it. Jannik was talking a little bit about it earlier. We know how long this is going to live, and it's going to outlive your truck. That's for damn sure. And so it's a conscious choice. We only have one drawback. We cannot charge as fast as the others, but we also don't need that in working equipment because it's not used 24 hours a day. So this is the constraint of lithium-ion phosphate. We can place the components a little bit more intelligently than we could before. We had one solution before, but now we can move things around as we want. Now, sometimes if you have a street sweeper, it's a very good idea to have all the battery capacity directly on the front axle and away from the sides. But being able to move the weight around is actually quite significant in order to keep balance in different kinds of vehicles. So now we can move not only the batteries, but also the power electronics away in a standardized and modularized system, so that we can more or less configure any vehicle you have with standard components using the same technology, and a very, very limited, it means a very short bill of material, so to speak. It will be the same components, but they are pre-configured. Option 1, 2, 3, 4, it's just more of the same, basically. How much time have I used? Okay. But I don't want to talk so much more about it. I actually want to answer some questions about it, if there are some about this technical stuff before we continue. But right now, this is the offering that we're putting into the marketplace, and we are actively looking for candidates with our known customers, particularly for refurbishing some of the trucks that we gave you with electric power takeoffs. They are now some fleets out there running on CNG with electric power takeoffs already there. We can convert them to become electric, and that's what we want to focus on over the coming couple of years. So about 100, maybe 150 conversions over the coming 1 or 2 years are welcome, and we want to see that. We think there's a space there. There's a shortage of electrical trucks there. Of course, it will come. And the price is also coming down from the OEMs. But the fleets that are out there now really need they need to become electric, and we can do that also in these facilities that we now have available, or with our partners such as, for instance, ECAP. We also welcome specialized vehicles. If you have a truck, it can be with a particularly expensive body or application and so on. We also have the possibility to help with that stuff, be it a partial electrification or full electrification. Sorry, Michael, for stealing your picture. This is an iconic like the one out here. If there are, we can still also convert new trucks, and we can do still also on the existing platforms. It requires that we remove the engines, and it will not be cost-effective solutions. But sometimes it's just necessary. I mean, the iconic, for instance, is hugely popular on a very low wheelbase. But if you need that in combination with a high battery capacity, you need someone like us to do that conversion for the moment. That's also a window that we want to look at. That, by the way, could have been any truck. It could have been a Dennis Eagle or a Volvo or a Scania. And then there's this. We started, I think 4 years ago already, to look at the hydrogen solutions. And I had an idea that maybe it would be a good idea with a very small fuel cell and a relatively modest tank to make a cost-effective system that could charge that would run 24 hours a day. I got the idea from Danfoss because at that time, fuel cells suffered from being started and stopped and so on and so forth. And this might make an attractive hydrogen powered range extender for a truck. That idea kind of, was in the background for a while. It turns out that that concept probably isn't a way to go, because big and powerful fuel cells have come down in price. There are a lot of them. They are beginning to use mass production and so on. But still, the idea of a range extender, hydrogen range extender on an existing battery electric powertrain is something that we wanted to continue to work on, if not only to understand how it works, what are the implications in terms of supplying it with energy and so on and so forth. And that's the truck you see down here. Now, we built that together with our German partners in ECAP, using our powertrain, our batteries, and using ECAP's fuel cell powertrain. And I'm very sure that Florian will be more than happy to show you what's actually inside those boxes down there, because that's quite interesting. So from that, I will open up to questions now before we give the floor to Florian about the hydrogen. So go ahead. Yes, son.
I was just wondering what happens to the diesel engines you pull out.
Sell them up on eBay. Okay. No. Well, it's the customer's engine. It's his problem.
Okay.
But seriously, it goes for scrap. It doesn't have any real value. What has a value are the exhaust systems, catalysts, and so on. So that's actually what is being used. Other questions? Yes.
What is the driving range on such a converted
Your
truck?
key figure, what you should have in your mind when you calculate it, and that goes for most any vehicle. Maybe a concrete mixer is a little bit special. But what you should think about is that you need 4 kilowatt hours to compensate for each liter of diesel that you consume. So 200 kilowatt hours, which is roughly what our base system has, is 50 liters of diesel. That key figure is more or less accurate over the range. Empty truck going 80, round about 0.75 kilowatt hours per kilometer. That's another rough estimate that will suit any application. Long haul 1.1 kilowatt hour per kilometer. Yeah.
On this vehicle, which is the range extender? Is that the fuel cell or the battery?
Yes. What's the definition? But because the fast charging option, and that's actually the only advantage the fuel cell gives us as an energy provider, is that we can charge it in no time. So that's the range extender. In principle, this could have been a gas propelled or a diesel, small diesel engine running with a generator filling up the batteries. It could be either. But in this case, it's a hydrogen fuel cell, and that's what gives us a range, an extended range on the battery.
Yep.
And that can then be a big, a huge tank and a very small battery. Or it can be a very big battery and a small tank. It's in principle something that can be worked with for the application. Yes.
Are there any types of working vehicles where you still haven't solved the issue of finding place for batteries, or is it all solved?
The most challenging truck is the big sewage vehicle. That is the biggest challenge, because more often than not, these are 4-axle vehicles. They have a big tank and they have an enormous power demand, because it works on vacuum, and moving air is energy consuming and power consuming. And there's almost no space for the battery packs, but it can be done.
There's one already, isn't there?
There are several, just not made by us.
Okay.
Super. Then Florian, show us what's inside that.
Try my best.
Yes, thank you.
Thank you, Rasmus,
I'll go over here.
for having us. It's an honor to be here, and it's a very nice audience. We had many nice talks today already. Thanks a lot for that opportunity. So I need to.
You can just skip that one.
Want me to tell that summary?
No, it's okay. I think it's
Okay, so we are the company Clean Logistics and ECAP. So I'm a little schizophrenic person. I'm CTO at Clean Logistics, and I'm managing director of ECAP currently. So whatever name you call me is right. And we are the guys building colorful trucks. That's the message. I'm 20 years old, I have 15 years experience in the industry, so whatever works for me. And that actually is hydrogen, and technically Knut is probably the better guy to explain this to you from Everfuel. And why would we even consider hydrogen as a fuel? That's the initial question I would like to ask you. And if you have good ideas, just shoot them to me. I'm looking for that. But we learned just from Rasmus, a lot of vehicles can be driven battery electric. And that's certainly true, especially in municipal applications, regional city transportation. That's exactly the way to go. Go battery electric. It's the most efficient you can do, especially if your truck sits in the yard overnight, for example, and you can charge it quietly and smoothly. If you're talking about high energy vehicles or pump vehicles, for example, or long haul vehicles, we have a different animal in front of us. And hydrogen plays a significant role for us, even though there's lots of ideas for mega charging and so on. And I just had the discussion over lunch about missing parking spots, at least in Germany. We are short 20,000 parking spots, and we consider putting super or mega chargers in each and every parking spot for a commercial vehicle truck to charge. Somehow this seems an idea which could work 100 years from now. I'm probably retired by then. So what's left over, we need an energy dense fuel which we can charge or we can fill in a truck in a very short period of time, and we can run at least 500, 600, 700 kilometers. And that's the aim we are looking at. And we need to have our customers of those trucks or the operators of the trucks operate the way they need to operate it, not the way we would wish them to do so, because then they lose money and we have no idea on how they use it, at least very little. So we need a fuel, and the fuel of today, it's not the future, it's today, is hydrogen. And so the thing is, renewable energies can be installed. Renewable electricity is available when the sun is shining and the wind is blowing. So the missing link we are having in this entire food chain of energy here is the storage capacity. And storage is the key also for our change towards sustainable energies. So the missing link naturally is hydrogen, because we know how to produce it. Certainly we do not have the infrastructure yet. We do not have that many filling stations for it. We are building huge size electrolyzers today. We are building windmills, we are building solar farms, whatever, we are building it. It's not tomorrow, it's today, and it works. And we just need to get our asses up, sorry for my French, in order to use that energy. And we also had lots of discussion about how the big players in the industry are moving and how everyone is technically looking at things, and when they enter the market, it needs to be the very right spot. Yes, technically that's the case. But we have an issue with energy today. I believe we all face the geopolitical things in the news every day, and we can change it with battery electric and with fuel cell electric trucks. So the most important message is we need hydrogen. We need hydrogen for long-haul transportation, for high energy applications, and we need it to store renewable energies. And please, if there's any questions, give it to me. I try to answer, not promising. And that's pretty much stolen from an older presentation of mine regarding total cost of ownership. And that's also one specific item I would like to talk to you about. In the end, money and maybe trucks make the world go round, but there is no romantic feelings. In the end, you need to deliver that Coke to your customer. You need to swipe the cities. You need to get your garbage out of the cities. Whatever, you need to get the job done to a reasonable cost. Otherwise, no one's going to buy it. And I'm not that romantic guy to promise you tomorrow is everything's going to be fine. There is a very long transition ahead of us, but we can get it done. What supports that idea of getting it done is that there is a very strong trend already. And I believe in the passenger car, the tipping point is already reached. Battery electric cars are very common. Everyone who considers to buy a new car is thinking about, okay, it's probably not a gas car or a diesel car, it's probably an electric car. Fuel cell not that much, but electric car, I believe most of the people think about it. And the sales figures show it pretty much. So additionally to that, I personally hate to go to a gas station. It's always cold in the winter and too hot in the summer, and I need to wait until the vehicle is filled up. I just plug it in at home and start the next morning. So it's convenient for a lazy guy like me. On top of that, the fluctuation and the price turbulences we faced in the last couple of weeks on LNG and diesel fuel is not giving the operators of commercial vehicles a lot of chances to calculate their business at least in the near term and not in the midterm. No one ever thought about paying €2 per liter of diesel a year ago, for example. And same happened with CNG, for example. A couple of years ago, CNG was the shit to go, and that's super cheap, and let's do it. Today, let's say it's a nightmare to fuel your vehicle with CNG, at least cost-wise. Not to drive it, I mean, it works, but the cost is a disaster. So we see that part of the game, that we cannot rely on stable gas prices or diesel prices. What we can rely currently on is that the European government and the local governments in many countries in Europe are aiming to install huge programs to support new energy. Hydrogen, battery electric cars, fuel cell electric trucks, for example. We got lucky in Germany that we have an 80% subsidy from the government for the delta cost between a diesel vehicle, diesel truck, and a fuel cell electric truck or a battery electric truck. So 80% of the additional cost will be recovered by the government. And that's beautiful to start. Technology readiness, that's also something a lot of people are wondering about. Yes, that's too new. I don't want to be an early adopter. I don't want to be whatever. I'm not the rabbit trying out all the new technology that other ones do it. This changed dramatically in the last 5 or 6 years. So when I started with commercial vehicles, zero emission commercial vehicles in 2015, there was industrial components and you could not find any qualified automotive parts. But today you have a variety of at least first generation, even second generation of components which are fully qualified, which are automotive ready. And we are facing the third generation with huge steps of improvements, like weight-wise, package-wise, functionality, efficiency, and so on. So there is a lot of movement still, but it's ready to go, and it's reliable. And luckily, we see a lot of logistics companies coming to us today and willing to try out this technology. So that's, I believe the curiosity is there. The market is there, let's just get it done. In China, for example, I always need a picture on my slides, otherwise I don't know how to orientate myself. In China, they just do it. They build hundreds and thousands of vehicles, learn with those vehicles, while we are still hesitant on the way to go. And to me, the worst word you can give, or you can yell at me, is technology openness. Technology openness is the case or a situation where I don't know where to go. To me, it's quite certain where to go. So that's the overview on what we're currently facing. As I said, functionality, durability, and certification is not an issue anymore. Even bigger tiers, like bigger suppliers, are entering the market with solutions Bunker already developed. We talked about some of the competitors last night. And all of the new players, even though they are huge and big in the market, they know little about the application. And that's the opportunity of established companies like Bunker, for example, knowing their applications, knowing their customers, having the right solutions. And that's 10 plus 1 year advantage, I believe. So on the powertrain side, and that's pretty much our business, the small components, for example, in DC-DC converter, the next generation we get next year is half the size, same power output. Just by changing some ingredients, truly there's development to be done, but that's huge steps you don't face in the diesel engine or diesel vehicle. There is hundreds of kilograms reductions in tank systems, for example, also in fuel cell systems or in batteries. And that's tremendous steps towards competitiveness. Also, the cost is pretty much the same scale. Today, we are showed on the next slide. We are at about 5 times a diesel truck or a fuel cell electric truck, long haul. But the cost reductions in the next years is huge. And we believe competitiveness is there. The only challenge I face as the technical director of such a company is that I cannot design a truck today and sell it for 7 years. That's not going to work. So we need to be up to date on component sides. We need to be up to date on the technology in order to participate on all these items. Otherwise, the truck I built today is old next year and you don't want to use it anymore. So this changes an entire industry and an entire process on how things work. And that's why I believe strongly that smaller companies like Banke or us, for example, or many others in that business do have an advantage, because we know today what the customer wants. We know today what the best solution is for that, and we participate on the huge steps the industry takes. Plain numbers. And that's the easy part. I call it the foreseeable. Today, our cost for a hydrogen truck, as I said, is about 5 times a diesel truck. Battery electric truck, Rasmus just told you it's about 400, a little less than 400 maybe in the comparison, but not ready for long haul. And today, that's not a price level we can accept for a very long time. With government subsidies, yes, that works. And in the very midterm, and you see almost 100,000 euro steps in the year in the next year, and until 2025, probably another 50,000, maybe it's more in decrease. So we're coming closer to diesel, but still will not reach it. Like the technology we have today, I don't see a cost competitiveness on the initial price within the next 5 years. 2030, 2035, maybe, because the components we use are technically very simple. Very little moving parts, chemistry, mass production is still not there. That's why the prediction beyond 2025 is very difficult. What we can predict pretty well is the fuel cost, because we got guys providing hydrogen. We see there's lots of capacity to be installed. There's infrastructure, there's pipelines, there's whatever is needed for that. And but that's not the slide. So on the component level and on the trucking, on the truck cost, that's going to be a slower process. So fuel cost, and we also had that talk earlier today. A hydrogen vehicle, hydrogen fuel cell vehicle can be competitive today in terms of fuel cost, especially with the high diesel fuel or high gas prices we have. We are on a competitive spot every once in a while, but I believe that tendency is going to be in favor of hydrogen and also on battery electric trucks. So the assumption is that we see a constant increase in diesel fuel. I believe that's no huge surprise. It's because of CO2 taxes, it's because of availability of oil and so on. But we also expect a strong decrease in hydrogen, and we also, after maybe short turbulences this year and next year, we expect electricity cost on a public station. It's not your industry electricity on your backyard. It's a public station price will become more cheaper. And just because of the scale of the industry and the amount of energy I can sell, because the infrastructure, once it's there, it just works. There's no wear and tear, almost nothing. And the more vehicles I have on the road, the more profitable my business model gets as an infrastructure provider. So we believe that latest 2024, we are competitive on the fuel side, and that's the biggest part of the total cost of ownership, except the driver. Driver is always the same, pretty much, as long as we're not having automated driving. So comparison to diesel, starting in 2024, we are able to compensate the higher initial cost of commercial trucks, battery electric or fuel cell electric, with the fuel cost or energy cost in daily operation. And that's that's the headache. What happens when I buy a diesel car today for my private purpose? For how much euros can I, or krone, I can sell it in 5 years from now? Is there a market for it? And that's exactly the question we are seeing in the commercial truck market. We have huge steps in legislation 2025, 2030. And after that, plus increasing diesel cost, who's going to buy that truck anymore? What happens to my depreciation? Do I need to put 5 years, or can I use 6 years or 7 years, depending on my operation? There's lots of struggle in the industry, because if the change happens if the change happens as fast as in the passenger car, 3 years from now, we are not talking about diesel anymore, because everyone is trying to get an electric truck, for example, or a fuel cell electric truck, and the resale values drop. Same happens, by the way, in the bus market. Someone said it earlier. Most of the cities convert to electric buses. Who's going to buy diesel buses? Euro 6 diesel buses are not even sold in Africa anymore, because no one is able to maintain those. It's a huge problem. And that's why also conversion comes into place. Even buses can convert it, trucks can convert it after the first service life. It's easy. Somehow it's possible to convert them into electric trucks, and it's possible to also convert them into fuel cell electric trucks. Give them a second life, support the idea of circular economy, and reduce the risk of depreciation errors in your calculation. And this I cannot predict. So that's why it's more or less a headache and a crystal ball. Rasmus introduced it earlier. Together with Banke, ECAP built the first iconic, based on a Banke powertrain, with a range extender, fuel cell range extender built by us, and an 8 kilogram tank system on the other side. So I only have technology pictures here. The overall picture you've seen at Rasmus' presentation. And we believe, even though battery electric is for refuse truck probably the way to go, there are competitors out there selling new vehicles based on hydrogen. Range extending, mostly relying on battery, depending on your application, and sometimes it really makes sense, and also depending on the availability of green hydrogen, for example, the cost of green hydrogen in your local area, it can make a lot of sense to go for fuel cell electric drives or fuel cell range extenders. For example, in Wuppertal, availability of not green but gray hydrogen is at €2.80 per kilogram, and you cannot even charge your vehicle that cheap. It's just excessive hydrogen from refineries and from chemical processes. So there are already spots in this world where you can have good access and where you can have a reliable business case for those vehicles. And then such a vehicle makes total sense. Or you have a huge range and a huge region to serve. Then this is also a very good solution. But please consult us, Rasmus, Banke, et al., or us in order to find the right setup for your application. And that's paramount to us. We would like to understand your application and get you the right technology. Okay. So since there is no business like show business, I had to put this here. We had our world premiere of our Powertrain trucks. You can see outside, and you actually saw it moving, so it's not going downhill only, it's going uphill as well. So we had the world premiere last week. We are very proud that our truck won the race against the diesel truck. as I said, a little show business, a show needs to be done. And we are going to sell this truck beginning now. And we already have a huge order intake. So since I'm more from the reality department, technology and manufacturing, it's all on my back now to build those trucks. And I'm trying to not get as many orders currently because we need to build them. No, and we are installing capacity currently for even more trucks. So we are planning to have about 100 trucks next year, and we are aiming for 10 to 12 this year even. And there's lots of work to be done still, but we are quite certain that we can get this done. Some facts of the truck, and you can ask me or my colleagues at any time. I can probably tell you everything about that vehicle. We have 2 fuel cells in it, 120 kilowatt each power output for the production version. We are operating those fuel cells in an optimum condition, so probably at half the power capacity they have, sufficient to power the vehicle. That's between 120, 150 kilowatts in average. That's what a commercial truck in that size needs on a long haul application. And therefore we have a very good efficiency. We are going for a 93 kilowatt hour battery, so it's quite small relatively to the energy amount needed. But we use the battery mainly for recuperation and peak power output. So it's the main power source is hydrogen and fuel cells. We're having 40 plus kilogram, 43 kilogram to be exact, on the truck installed. This is okay for 500 kilometers, and especially with the item underneath, which we developed on our own, an axle beam with wheel direct or wheel hub drives for higher efficiency. We believe that we can even beat the current setups on the streets in terms of efficiency, because we have no gears anymore, we have no loops. It's a wear and tear free setup pretty much. There's no maintenance to be done on those wheels and those drives. The limitations we have is on the torque. So currently you would expect a commercial vehicle in a 40-ton class to have 50 to 16,000 Newton meters on the wheels in order to get going. And you would probably need that if you are in a gravel pit or if you're in a mining application or you need to do some magic with the truck. But for a very standard long haul application, going between 26 to 35 tons, that's fairly enough. And that's tested. And we believe tailoring the technology to the actual needs of the customers is the way to go, and not building a one-fits-all solution, which in the end carries too much weight or is too inefficient in the specific needs. So we will certainly have different setups of electric drives for our trucks, but that's the long haul setup, and we are moving forward with that, even increasing the torque in the near future. That's the little secret sauce we put in, and also here we are happy to explain. As a group, what happens next? We are about 120 employees today. On Friday, July 1st, it's 10 more. And that's pretty much the growth rate we are facing. So I need to learn 10 more names every month. It's incredible, and it's nice to see. And we also earlier discussed, okay, the industry we are in with zero emission technology, with fuel cells, with hydrogen, it's kind of sexy, and we are not short on applications. But if you want to apply, come on over, please. Strong order intake, I already said. We are building production capacity, and we are going to have external partners to build our vehicles in the very near future. And we have a different brand strategy. So Clean Logistics, the one hat I'm wearing, is going to face, going to build the volume production for us. And ECAP, especially like seen outside in a project with Rasmus and the Banke team, is going to focus on special vehicles, mobile machines, and prototypes. And ECAP, in this case, is our R&D and knowledge department, whereas Clean Logistics is more likely to be the manufacturing side. But the brand of the trucks once you buy such a variant out there. What we're also considering in the near future is extending our product range by powertrain systems for special OEMs, or for some OEMs who are not having a capacity, but are in niche markets, for example. And that's a very common business, used to be very common in the bus segment, used to be very common in the special vehicle areas. And we are going to provide electric powertrains for those guys as well. That's pretty much Clean Logistics and more even ECAP at a glance. And I'm happy you listened without disturbing me and without asking questions. So please follow up on that. I need questions, otherwise I stop talking.
You had this graph where you showed that the cost per kilometer is lower for hydrogen than for, and then chose public charging.
Yeah.
I guess many trucks will run on depot charging.
Yes.
Which probably is cheaper.
Yes, that's a lot cheaper. So that's what you're paying today on a public charger is not competitive. Yeah, that's the, if you need to, you have to, but that's not the way to operate a truck. Or you have a special flat rate or special rates because you have a huge fleet and you come every day, something like that. But to make it somehow comparable, because with a fuel cell truck, you probably go long haul and you go to a public fuel station. And that's the competition we are facing. That's why I put it here. Certainly on your industry yard or in your depot, you have perfect rates and you have perfect prices for electricity, but that's what I said. Please go for electric trucks then. That's the best way to go, the cheapest way if you have access to your depot, if you can leave your vehicle 8 hours over there, go electric.
I just want to comment. I fully agree that the calculating a residual value on a diesel truck in 2028 is pretty hard right now.
Mm-hmm.
But I would say it's also pretty hard to calculate the residual value of a zero emission truck in 2028. So yeah, it's a common problem.
It is certainly. So that's a secret I shouldn't tell. But anyhow, so since we have a very modular concept and we are going to plan a similar concept like Tesla did on software over the air updates and so on, we are planning actually even already today to upgrade our vehicles in 5 or 6 years. So after the first service life, for example, we would replace the batteries if needed, or we refurbish the batteries if needed, depending on the technology. Same as Yannick said earlier today, after 7, 8, 9 years, the truck itself works, the equipment is okay, a few parts might be not okay and we replace them and they are ready to go. I personally want to avoid throwing away functional vehicles and functional technology. I'd rather maintain that.
Yeah. Do you know, are there any OEMs making hydrogen stuff?
Not for sale. At least currently not that I know. So there might be Nikola in the near future, providing fuel cell electric trucks. There is Hyzon in the same business as we are, and I don't think that's a competition because that more or less proves our business model that there is a way to go. And there are many others like Pepper Motion in Germany converting buses, but also trucks. And Paul introduced a medium duty truck earlier this year. So there is other companies doing the same thing, and I can only invite them to be successful. I want them to be successful because that gives us all the chance to change the industry to a certain degree.
Yeah, but why are the existing OEMs not more active in this field, or the traditional OEMs not more active in this field? Did they miss something, or?
Would you murder your cash cow just because the sausage is good? That's the problem. They have a legacy business which is very profitable, and it's even more profitable today with the shortage of components and shortage of supply. And just last week, there was a big article in the news. Daimler Truck sold out 2023. There's no vehicles available anymore, and they raised the prices. So they are in a very, very comfortable position currently. And still, they introduced battery electric trucks already, and they will introduce fuel cell electric trucks probably in the ballpark of 2027, 2028. But they cannibalized their existing business model. So where's the motivation in order to move faster? That's my 5 cents for that. There's probably a lot of other information, a lot of other intel. But I've been working the last 7 years in that industry, and as I said, 6 years ago, everyone was saying, okay, we go 20 years with diesel, and after that, probably another 20 years. There's no real motivation to destroy their own business model. So you need to have external triggers in order to move.
We have those triggers.
Huh?
I'm from Mercedes-Benz. Hello.
Very good.
I mean, we have a 30% reduction goal from the EU, so we
Yeah.
need to do
Yes.
zero emission vehicles. Quite a lot actually, and if you look at the Fit for 55 program from EU, we actually need between 50 and 60% zero emission vehicles by 2030. So the ambition is really there. It's not a question if we're going to do it or have a cash cow or whatever.
Yeah.
We have to do this,
Right.
and we also support it.
Yes. So that's no offense, but certainly you're happy to sell a diesel vehicle today. I don't have a diesel vehicle. That's the little difference we have, and I want also to be Daimler Truck to be successful in selling battery electric vehicles. You just introduced the e-actros and e-iconic, and it's perfect. And certainly, if you do the math for 2025, that's not feasible with a diesel vehicle to reach. In 2030, impossible without a huge volume of zero emission trucks. Still, you're not the first mover, and that's why I left Daimler Truck. I'm an old colleague of yours. I would like to be somehow a pain, even in your back, in order to drive this technology, and that's my motivation. It can be done, and you just proved it with your vehicles. It can be done, and it will be done. Just the pace is different.
Actually, our capacity exceeds the customer interest at the moment. So
Yeah.
we are order producing in the company. So if there was bigger demand for zero emission vehicle, I think we could swap. But right now, there's no business case behind it. So we have to produce what our customers actually want to buy.
Yeah, that's true. And that's certain. So we are probably a group of people here which are interested in new technology and which are crazy enough to try that. And there are some, at least after last week, I would say a lot of people willing to try, but certainly they will try and they will test those vehicles, and the adoption rate will be slow. But we are not building 10,000 of vehicles. We are building 100 next year, and we are aiming for more the year after. So we are in a different spot.
How do you see the split 15, 20 years from now between diesel fuel cell and electric?
I believe 15 years from now, we still have diesel around for special vehicles, and there will be a need for those. I don't think that's going away entirely, but let's say starting from regional bus application, for example, regional delivery, city applications like garbage and so on, where zero emission technology can be adapted fairly fast. You can move on to mid-hauling or to hub traffic, and then you go to long haul, and the adoption rate is going to grow. But still, in many applications, I can imagine mining, for example, where you have a very, very huge energy consumption. Diesel is still the way to go. But the share is going to move more towards zero emission. Over time anyway. Okay, then if there's more.
Okay, well, thanks, that's right. Really informative, and the video was nice. We'll take a 20-minute break, and then we're back here for the debate at 3:10, 3:15. Okay.